If g of y is equal to y to the 2/3 power and a does not equal 0, find g prime of a. Well, let's take a look at the definition. So we have g prime of a is going to equal the limit as y approaches a of g of y minus g of a divided by y minus a. So taking the limit as y approaches a, well, g of y is y to the 2/3 power minus g of a is going to be a to the 2/3 power, and then we're going to divide that by y minus a. Okay, so let's take a look at the numerator. Okay, so we're going to expand the numerator and then we're going to expand the denominator. If we take a look at the numerator, okay, we have a difference of squares scenario. What I mean by that is we have y to the 1/3 squared minus a to the 1/3 squared. So therefore that is a difference of squares. What does the actual difference of square mean? Well, that means that we have y to the 1/3 plus a to the 1/3 times y to the 1/3 minus a to the 1/3. And so therefore in our second step we have, or our next step, the limit as y approaches a. In our numerator, we can expand this now to be y to the 1/3 plus a to the 1/3 times y to the 1/3 minus a to the 1/3. Okay, now let's take a look at the denominator. Okay. What we want to do is we want to make sure that this denominator is going to resemble something that we can simplify in the numerator that we just expanded. So we know that y has an exponent of 1 minus a to the exponent of 1. Now we also know that 1 can also be written as a fraction. So if we wanted to have a denominator of 3, this is the same thing as saying y to the 3/3 power minus a to the 3/3 power. Okay, which then means what? Well, what this means is kind of similar to what we just did in the previous step. We know that we have y to the 1/3, and that can be raised to the 3rd power, minus we have a to the 1/3, which is raised to the 3rd power. What does that mean? Well, that means that we now have the difference of cubes. So since we have the difference of cubes, we're going to look at that formula. And what do we know? We know in our problem, we know that a is going to represent y to the 1/3. And then we know that b is going to represent a to the 1/3. So now let's plug it into our formula. So we have y to the 1/3 minus a to the 1/3 times y to the 1/3 squared plus y to the 1/3 times a to the 1/3 plus a to the 1/3 squared. Now let's go ahead and simplify that a little further. So we have y to the 1/3 minus a to the 1/3. And so we end up getting y to the 2/3 plus y to the 1/3, a to the 1/3 plus a to the 2/3. So now let's go ahead and then put that now in our denominator. So we have y to the 1/3 minus a to the 1/3 times y to the 2/3 plus y to the 1/3 times a to the 1/3 plus a to the 2/3. And now, is there anything that we can simplify with the numerator and the denominator? And we can simplify those two. So now what's left is y to the 1/3 plus a to the 1/3 divided by y to the 2/3 plus y to the 1/3 a to the 1/3 plus a to the 2/3. So now let's go ahead and then evaluate the function. So we're going to now substitute the y's for a. So we're going to get the following. We have a to the 1/3 in the numerator plus a to the 1/3 divided by a to the 2/3 plus a to the 1/3 times a to the 1/3 plus a to the 2/3. Now let's go ahead and combine in the numerator. So in the numerator, we end up getting 2, if we add those together, 2 to the a to the 1/3. And the denominator, when you multiply those together, you're going to get a to the 2/3. So that means you're going to have 3 of them. So we have 3a to the 2/3. Okay, now remember that when you have the same base and you're dividing them, then you subtract the exponents. So you have 2a to the 1/3 minus 2/3. And that's 2 over 3. And that's equal to 2/3 a to the negative 1/3. Or we would say 2 over 3a to the 1/3. And therefore that would be our result.